Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and this is Boat Forks, Part 7. All right, we're down here on the mats of the floor here, and we got our pieces together here. And you can see I got suspension on the crane here, so that we got some capabilities of moving around here. We're doing a few things with these before they're released, and heading back down to the yard to go ahead and clean up paint and be assembled onto the fork truck there. One, the grease fitting here, we put the two grease fittings back in here, and that's where they were. And the reason why they want to tag a line here and run a grease over to another area is when that big box is in here, they are, I don't know, I think my guess they're 10-12 foot long. So when you're operating, and this is down at ground level, and you're warming up the machine and stuff like that, and you want to lubricate these, you could not do it in a position. You have to raise the carriage up high enough to where the drop forks go down through here, and then you're up that much up in the air, and then you can get to this zerk fitting. Now they also pivot slightly here, and we're going to be pivoting a little bit here, because I'm going to go ahead and relocate this zerk fitting. Okay, and this zerk fitting can't be just put back in here, because when this elevates up, and we're going to see that in a minute, this straight edge here comes down, and you would be clipping this. These are two blocks here that come in, and the upper part of the carriage is right there, but this thing is allowed to tilt back at least to that distance, maybe not quite as much, but pretty close to it. So that would be enough to damage that fitting. And it doesn't matter if it's a compression fitting or a flare fitting, that 90 or that elbow is so high that it would be interference there. We're going to leave these right in here to plug the hole, and they'll be in there just to keep everything closed up. And we're going to drill and tap two new holes for the elbow to fit into. And here it is. We're going to go ahead and radius this out slightly, and we're going to weld this stainless steel coupler. We'll be able to run the zerk out of that one in, and another compression fitting, and then we'll have just a short little piece of tube just like that piece is in there. One of the things that they requested, or they were talking about, and that is how short this pin is, and you got to slide it in through one opening. It's blind on the other except for a little hole, and you got to jiggle this thing around to get this in there, and it's very hard to have that almost all the way in there and get it into this last diameter holding, which is that you can see on the pin there, it's that color. What I did is set this up in the lathe, and now we're going to go ahead and we're going to put our 1/2 inch 13 tap in here. Now we drilled this out 1.5 inches. We only need to have 1 inch of tap up here, so we know 1 inch of tap is going to bring about 1/2 inch from the end of the thing here. We're tight into the chuck. We tightened our quill. We loosened our tailstock nut, and we're going into slow speed. A little bit of coolant. Cutting oil is what it is. All right, we grab the tailstock. We slide it in. Boom, connects. Right about there is about 1 inch of threads. That's all we need. Reverse it. Come back out. Alright, slight bit of pressure on the tap and it comes out free. Drilled and tapped them a 1/2 inch hole so that you can just stick a bolt in here, and then the bolt will stick through the little hole on the other end, and then you can lift it with your hand and you can get it in there. And let me show you how easy that is. Okay, pull the bolt out, and you're all done. All right, now that we have that in there, I can go ahead and put the straight edge in here, and then I'm going to lift with the hoist, and then you can see that the angle of the beam that would be in here, of course, it's not going to go past those blocks right there, because I know that the carriage sticks out that far. Okay, so the regular zerk fitting's cleared, even with the most amount of movement of tilt on this thing. And it would probably be rare that the extension forks would be in there and you would be tilting it, but that is the full motion of the machine. And if it can go there sometime or another during operation, it probably will go there. All right, with this at this angle, we can take our 90 and even at its highest point, meaning it's not screwed in, you know, once it screws in, it'll be able to drop another 1/8 of an inch or so, and we'd say somewhere around in there. We'll just safely say right there. All right, and we take our center punch and we put it right there, and we're going to come over 4 1/8 from this outside, or 4 7/8 I should say. That'll put us center of the grease groove, and we're just punching it, marking it right now because we're going to drill it when everything is off of here. Okay, and we will double check that both directions. Looks good. All right, we're ready to pull this out. Now, when we have this out, we're also going to be redoing a few things. They had shim packs that went in on each side of these pins. Can you imagine trying to get these and that pin in there? What we're doing, we went ahead and took the full measurement, and we burned out on the plasma table 2 solid rings. And this was 3/16 plate, and 3 of these washers here came out to about 150. And so what we did is we took these and set them up in the 4-jaw, and we faced off till we got the thickness to fit each piece here. That one's a little narrower than this one, and we're going to set this up and we're going to pull this apart. We're going to set this up on the table. We're going to clean and prep that, and we're going to put this down in place with the pin in, and then we're going to clamp it down, and we're going to tack weld this washer in on this side. We're going to tack this one in on that side, and then down at the bottom foot there's a pad that comes down, and it locates side to side down at the bottom, and we're going to match that same gap down at the other end so that we will be locking this into the carriage and getting rid of all of that play right there. Okay, so 3/16 of an inch in 4 foot makes up a couple inches, 20-30 foot out on the end of the forks. This is, you know, combining new bores, making this stouter. This has already been shimmed, so the box in here fits snug enough inside here. So a little bit here, a little bit there, and we'll be making up all the play that's been in this thing for years. This is a very old machine, but it is been restored. Got a really nice, beautiful paint job on it, and I'll be getting down there and we'll see this thing all together. So, all right, let's go ahead and pull this apart and get it set up for welding those pieces in. All right, we got this plate just floating in place. It's paint underneath has been cleared off. The paint underneath this one's been cleared off. We put the ring down. We dropped the pin in there, and we put that so we got a good eyeball of clearance all the way around that pin. Now we're going to go ahead and we're going to start on this one here. We're going to tack it in a couple places here, and then we'll go over and we'll do the same thing on the plate. And then we're going to give them what it's going to take to actually hold them in place. All right, and I want my tacks to be as close to where I'm clamping, and then I'm going to bring the clamp around. I want to make sure that that gets down hard all the way around. And the same thing with that there, because they are shims to this surface. So if you let this rise, then you're going to create more tightness than you actually want, and we'll end up having to grind a little bit off of that. So this is less less work if we set it up right. All right, here we go. Okay, our ground. We want to make sure our ground is on good here. Let me bring it around here. Slip it right on there. I almost was going to go ahead and check the polarity on the machine, but I know I was using the machine and stick welding the very last time. So, okay. Just gotta make sure you got a good ground. All right, now we're gonna go ahead and pull our pin out. One, we don't want to get any splatter on it, but we also want to be able to look into the crack and see that we're down all the way. And I'm going to bend that like that. I'm going to break the flux off of there. Okay, I want to get on that back side in there. So I'm just going to reach around in here and hopefully don't touch the back of that rod. And okay, we want to make sure that this is solid around here, and we're going to go ahead and we're going to roll that in there, so it's going to be like a little bit of a ramp going in there. Okay, we drilled and tapped, we screwed on our flared fitting, and this will fit onto there, and we'll curve it around here. We already finished welding up our shims that are going in there, and we want this zert fitting to be right out here, and then the other one will be right in here, just as right about there. They'll be about 2 inches apart or so. And I kind of like that area right there. So what I'm going to do is I'm going to take my little whizzy wheel, and first I want to go ahead and I just don't want to shoot sparks into there. Okay, like we said, right in there. We like that. I'm just giving it a little cradle to sit in here, like that. Once I get it in the right position I want it, then I'm just going to take the paint off of around the outside edges here. I kind of like that. Let's bring this in a little bit. Okay, I like that. Okay, let's take the paint off of here now. I like that. We're only going to put just a tiny bit of weld on both sides of there. We're not going to put a whole bunch of weld on there. We're not going to try to contract this or de-shape the bearing, bushing in here. You know, this is pretty close into the web. There's plenty of weld right here, and we're just going to basically be tacking it there and there. We're going to be well away from that bore right there to make any action to pull, I think. Especially for the amount of clearance we got in there. Okay, we got that clamped in with our little reach over clamp, and I went and got a piece of my 309L because this is 316 on the fitting, and we're in a steel atmosphere here, and it should should blend real nice in there. All right, our stinger, follow the lead. Okay, here we go. And on the other side here. Two little spots like that. That's all we're going to need to hold that on there. Okay, and we'll let that cool, and we'll knock off the slag, and we'll save that rod for the other one. I like that. Okay, we'll let that cool down, and we're going to make up that line while we got it right here. And then this one is ready for a test fit. Alright, we're all set now. We welded in our shims, and we welded in the little straight pipe fitting so that our tubing compression fitting can fit in one and in the zerk in the other. We take our scale and we measure over from the flare to the center. We set up our tubing cutter with that same dimension there, and we go ahead and we bend in the curve that we need to appropriately line it up with the other fitting. We put it in place, and then we slip a spare piece of tubing inside, mark it with a Sharpie, and then hold that up to the mark we did, and we mark off how much sticks into that fitting, and we go ahead and we trim it off with a tubing cutter. Put it in place. We're good to go. Nice little short piece of tubing. That's all we needed. Alright, we set in the secondary assembly that pivots inside this frame. It carries the forks. And we've got both fittings sticking out the same side. The shims are holding that gap. It'll never, the fittings will never come any closer to the side than that. It's the lower space. Nice ramped in surface so that it slides in there easy. We lifted it up slightly out of the receiver that it sits into so that we could get the max or the travel that we know that it would tilt. And we put a straight edge inside and make sure that we had proper clearance over the fittings there. So we're proving that, and we're all good to go. Alright, our customer has already picked up the fork assemblies. They've gone down, they've assembled them, and they're happy with how they feel and tightness. They're going to go ahead and paint up those accessories there, and then fully assemble them and grease them up, and they'll get the thing ready to rock and roll for their season that's starting, or going to be starting soon. We've still got a lot of boats under wrap, and so it's going to be a little bit. They said that they would give me a call, and when they get it in operation, and I'll be able to go down there and we'll get to see the thing in operation there. But until then, here's a photo that I found of it online when they had purchased it 10 years ago. Okay, before I let you go and we close out on this video series here, I wanted to hit a little bit of information there on the press fits and the clearance that I gave that bushing. Basically, you know that I machined it and I had an interference fit, and I put it in dry ice and I dropped them in there, and it's good to go. Two things that I was looking up, and I looked up the ISO chart for bronze bushings. And basically, it stated that they wanted H8 fit, which for that diameter and everything else was plus 54 to plus 63 micrometers. which are 2 1/10 of a thousandths and 2 4/10 of a thousandths for those size that we did. I actually shot a little bit on the high side, and I gave those about 3 thousandths press. Now, there's no real formula that you can figure in unless you're doing exactly the same size bearing time and time again in the same hole, and you will know how much the inside will contract from the press that you put on the outside. There's a general rule of 70 to 105% of that press fit will transfer to the inside, depending on the wall thickness of the piece that you're putting in, depending on the type of material. There's a lot of different variables that are in there. So you gotta just make your best judgment that it is what it is, okay? That aluminum bronze is really stout material. Got a good wall thickness on it. And it didn't give me but maybe 70%, maybe, if that, of that press fit in there. I didn't shrink the bore as much as I thought it would be, so I came out on the heavy side of my running clearances. Running clearance is the clearance that is set forth in the machinist's handbook here, and there's different running clearances, and they're categorized between 1 and 8. Okay, 5 and 6 in the characteristics of that running clearance is comparable to the weight load, because that they judge it by the speed of your bushing or rotation or the weight load. And so anyway, I went ahead and looked on the chart here, and our diameter that was in here for a 5 to 6 was anywhere from 3 thousandths to 7.4 thousandths clearance. And I ended up having about 6.5 or 7 thousandths clearance on those bushings, which I'm good with that. Nothing worse than having that thing shrink in too much and be on the low side, and then having poor performance because you are too tight. All right, so I just want to highlight on what I actually had for fits and what I actually used to judge those fits. So it was just national standards that I found online for the bushing bearing material, and it was running clearance allowances in the machinist's handbook. All right, until next time, get her done.